Hi everyone, welcome to chapter 5 States of Matter. So today we will look at Dalton's Law. So for Dalton's Law, it states that the total pressure of a mixture of non-reacting ideal gas at constant temperature is the sum of partial pressures exerted by each of the gases in the mixture. So, the partial pressure is the pressure that a gas would exert yang dapat dihasilkan if it alone is present in the container. So, maksudnya dia tak berkaitan lah. Maksudnya, if you have gas A, maksudnya if you have gas A in here, so the partial pressure of the gas A, okay, is not affected by other gases. So if you have gas B in here, so you will have partial pressure of gas B. And then if you have gas C in here, you will have partial pressure of gas C. And if you want to find the total pressure, it is the sum of the partial pressures. So PA plus, you have here partial pressure of gas A plus partial pressure of gas B and plus partial pressure of gas C. So you will have total pressure of the gases mixture. Right, so for example, the total pressure of the gases mixture, let's say you have in here is, okay, you have nitrogen gas and hydrogen gas. Okay, so each of the gases will have each partial pressure. So if you want to find the total pressure, partial pressure of nitrogen plus with partial pressure of hydrogen gas. So you need to take note that it only occurs in closed system. So according to ideal gas equation, PV equals to nRT. So if you want to use this ideal gas equation, therefore pressure exerted by gas A is PA, partial pressure of gas A, is equals to mole of gas A and then times with gas constant R times temperature in Kelvin and then divided by volume in liter. So if you want to calculate the partial pressure of gas B, so just rearrange the equation, ideal gas equation, and then you will get PB, partial pressure of gas B, equal to N number of mole for gas B times R, gas constant, times temperature divided by volume in liter. So for the pressure in total, if you use the PV equals to nRT, then later you need to sum up both of them. Okay. So you will come to this mole A plus mole B. So in this bracket, okay, so ini adalah your mole total. Or you can sum up ataupun tulis the equation in this form P total. Or instead of you calculate one by one, okay, so ini cara pertama. Ataupun you can also use this equation straight away if you have the mole total. So total pressure is equal to mole total times gas constant times temperature in Kelvin and divided by volume in liter. Okay, so if you have partial pressure of A, PV equals to nRT. Ini adalah for gas A. And then this is the total. Okay, PV equals to nRT, but pressure total and mole total. So you can also use mole fraction. How we can get this? Okay, so you can see for the first one, I highlight in green. Okay, so ini untuk gas A. So the one yang di bahagian bawah, PV equals to nRT, but this one is for the total. Okay, so if you combine these two equations and you simplify them, so you will get the mole fraction of gas A. So kamu akan dapat PA, partial pressure of gas A, divided by total pressure is equal to mole of gas A divided by mole of total. So this one you can simplify as mole fraction. Ini kita dah belajar in previous chapter. Okay, so you can rewrite them as partial pressure of gas A. If you want to find partial pressure of gas A by using mole fraction, kamu boleh guna this equation. Partial pressure of A is equal to mole fraction A divided by partial pressure T. So up to you, whichever formula or method that suits you and suits the question. Let's have a look at example 1. A mixture of gases contain 0.1 mole of CO2 and 0.3 mole of oxygen gas. Determine the partial pressure of the gases. So you want to find PCO2, partial pressure of CO2 and partial pressure of oxygen. And the total pressure here given is 760 millimeter mercury at certain temperature. So list out the important detail. So if you combine these two number of mole, kamu akan dapat mole total which is 0.4 mole. And then next, so to find partial pressure of gas CO2, so we can use, sebab kita ada information about mole, we can use the formula of partial pressure of gas that we want to find and times mole fraction with P total pressure. Okay, so if you want to find partial pressure of CO2, this is the formula, and then you will get the final answer 190 millimeter mercury. Next, if you want to find partial pressure of oxygen, still the same step, you just substitute into the equation, and then you will get your final answer 570 millimeter mercury. Next example. Okay, so read the question. A sample of gas at 5.88 atm contain 1.2 gram of CH4, 0.4 gram of hydrogen gas, and 0.1 gram of helium. So you need to calculate the partial pressure of each gases in the mixture. So for this type of question, if you find it is difficult for you to illustrate, so lukiskan the container and then write down the gases that you have in the container. Okay, so in this case you have CH4, you have hydrogen gas, and then you have helium gas. So you need to find each of the partial pressure. So in this case, sebab you are given with mass. So from mass you can find mole. So mole is equals to mass over molar mass. Okay, sebab you are given with mass of each gases here. Alright. So for mole of CH4, you will have 0.075 mole. mole of hydrogen gas H2 0.2 mole, and mole for helium gas is 0.025 mole. So if you want to find partial pressure of each gases, just use this formula. So just insert into this formula for each gases, and for mole fraction, okay, it is mole of the gases divided by mole total, and mole total is the sum of all of this. Okay, so kamu akan dapat 0.3 mole. Right, so if you substitute into the equation, kamu akan dapat partial pressure of gas CH4 is equal to 1.47 atm, and this unit for pressure depends on the unit you use in here. Okay, so if you use in atm, then final answer kamu akan dapat atm. If you use torr, then final answer mesti dapat torr. And then for partial pressure for hydrogen, you will get your final answer 3.92 atm, and partial pressure for helium, you will get 0.49 atm. Okay, so double check with your answer. Okay, so for question B, what is the partial pressure of CH4 and hydrogen gas if we remove this? So what if I remove helium? So if you remove helium gas from the container, the total pressure, you just need to sum partial pressure of CH4 and partial pressure of hydrogen gas. So when you want to calculate, so if you want to find the partial pressure of each gases, CH4 and partial pressure of H2. Okay, so you just use the same formula. Partial pressure of gas A equals to mole fraction of gas A times the total pressure. So in this case, ini adalah P total, masih lagi sama P total. It's just that now when you remove helium from the system, P total adalah PCH4, partial pressure of CH4 plus partial pressure of hydrogen gas. So untuk partial pressure of CH4 methane gas, kamu akan dapat 1.6 atm, and for hydrogen gas the partial pressure is 4.28 atm. Next is example 3. You have gas mixture and you are given with percentage by mass for each gases. You have CH4, methane, and ethane, C2H6. And the mass given, okay, so ini untuk cari mass of each gases. And from there, you can find mole of each gases. Okay, so you can use the information. Okay, so 82% untuk CH4, so 82 divided by 100 times with the mass of sample 15.5 grams, so the mass untuk CH4 is 12.71 gram, and then for C2H6 the mass is 2.79 gram. So you already have the mass for each gases. From there you can find mole. So mole untuk CH4 is 0.79 mole, and then mole for C2H6 ethane gas is 0.09 3. Okay, so untuk cari mole, mass over molar mass. So the mole total is equal to mole of CH4 plus mole of C2H6 equal to 0.883 mole. Okay, so untuk the next question, the total pressure. So you can use this formula from the ideal gas equation, PV equals to nRT. So just cari P total, total pressure means untuk mole kamu guna mole total. And then R is the gas constant. So substitute into the equation. If you are using PV equals to nRT, make sure you convert, okay, temperature mesti dalam Kelvin, and then for the total pressure you will get 1.42 atm. Okay, for the last question, okay, the partial pressure of each gases in the container. So you want to find partial pressure of CH4 and C2H6. Okay, so by using mole fraction, you can find, because kita dah ada mole untuk each gases and we have the mole total, kita boleh terus guna this formula. Okay, so for this question, partial pressure of CH4 is 1.27 atm, and for C2H6, the partial pressure is 0.15 atm. Next example. So the figures below show two connecting vessels containing different gas. One of them is hydrogen gas, another one is CO2 gas. And when the valve is open, the two gases are allowed to mix. So means dekat di tengah sini, you open the valve here. Okay, so when you open the valve means hydrogen gas will move to another container, and then CO2 gas will move to another part of the vessel. Okay, so the two gases will mix, and this part of the question, by ignoring the volume taken by the valve, means you assume the volume occupied here is too small, so it can be neglected, and calculate the partial pressure of each gases and the final pressure of the mixture. Okay, so for this example, if you want to find partial pressure of each gases, okay, so you want to find partial pressure of hydrogen gas and partial pressure of CO2, okay, you can use partial pressure of gas that you want to find, and you can use mole fraction times P total. Okay, so if you want to use this formula, okay, maksudnya kita kena cari P total dulu. So if you want to find P total by using PV equals to nRT, okay, kamu akan dapat P total, total pressure of the gases is equal to 0.75 mole, because you have here 0.5 plus 0.25, kamu akan dapat N total 0.75 mole, and then times the gas constant times the temperature in Kelvin and divided by the volume. The total volume here is 4 liter, so you will get the total pressure 8.05 atm. Okay, so if you want to find partial pressure of hydrogen, so 0.5 divided by 0.75 times the P total, and then you will get 5.37 atm. And then for partial pressure of CO2, okay, so tengok sini 0.25 mole divided by 0.75, the total mole, times the total pressure 8.05. So you will get the final answer untuk partial pressure CO2 2.68 atm. Okay, the next method is you can straight away use the PV equals to nRT by using ideal gas equation, but you straight away substitute for pressure. You find the partial pressure of hydrogen gas. So number of mole here should be number of mole of hydrogen gas. So you will still get the same answer. Okay, so either way is acceptable. Right, let's look at the Dalton's law of partial pressure. And for this method, it is called as water displacement method. So for this setup of experiment, okay, when you conduct this experiment with this setup, means a gas will be collected over water. So means you pass through gas here, and then it will pass through water, okay, and you will have this bubble gas, and then it will be trapped inside this container. Okay, so you will have gases inside this container. So inside here there are oxygen gas, for example, and water vapor. Okay, so if you pass through oxygen gas, so you will be collecting oxygen gas here and also water vapor. So the P total here will be partial pressure of oxygen plus partial pressure of water vapor. Okay, so take note here, total pressure kalau guna water displacement method, okay, mestilah hasil tambah pressure of the gas. So partial pressure of the gas collected and partial pressure of water. Normally ini adalah fixed and given in the question. So let's have a look at this example. So a decomposition of potassium chlorate KClO3 will decompose into KCl, potassium chloride, and oxygen gas. So a sample of 5.45 liter of oxygen is collected over water at a total pressure of 735.5 torr at 25 degrees Celsius. So, how many grams of oxygen have been collected in this case? So, list down the information. You have total pressure, and then you know the partial pressure of water. Okay, given here to 23.8 torr, and then you can use the equation PV equals to nRT to find mole total. Okay, so by using this equation PV equals to nRT, rearrange them to find mole total. You will get 0.21557 mole. Next, when you have the mole total, okay, so you can find the mole of water. Okay, so for mole of water, okay, kita boleh guna this formula. Okay, so you can substitute into this equation and then you rearrange to find mole of water. And next, you can find mole of oxygen gas, okay, from the rearranging the equation. And you will get mole of oxygen is 0.2086 mole. And then substitute into the equation to find mass of oxygen. So mass of oxygen is 6.67 gram. Okay, so let's say the question extended. Okay, contoh ditanya. Oops. Okay, so let's say the question asks you to find mass of sample KClO3 decomposed. Okay, so from the equation you can see 2 mole of KClO3, you will get 3 mole of oxygen gas. Okay, so if you have mole of oxygen here 0.2086 mole, okay, so maksudnya berapa mole of KClO3? Okay, so buat darab silang, you will get 0.2086. So you will have 0. So mole of KClO3 potassium chlorate is 0.139 mole. So if you want to find mass of this potassium chlorate, mass is mole times molar mass. So the molar mass of potassium chlorate is, so your mass for potassium chlorate, the formula of KClO3, kamu akan dapat 17.04 gram. Okay, so remember, if the method used is water displacement method, so water vapor will always present. So the P total here is the sum of partial pressure of any gases here, okay, plus with partial pressure of water molecule, and the vapor pressure of water is 23.8 torr. For the next question, sodium chlorate decomposed to sodium chloride and oxygen gas when heated at high temperature at 25 degrees Celsius. A volume of 325 ml of the gas was collected by water displacement method, and the total pressure is 768 mm mercury. Write the balance equation and calculate the partial pressure of oxygen gas and the number of mole of oxygen collected. Okay, so look at the first question. So this is the balance equation. So you have 2 mole of NaClO3 will decompose to 2 mole of NaCl plus 3 mole of oxygen gas. And then to find the partial pressure of oxygen, okay, just rearrange this formula and then tolaklah 768 tolak 23.8. This is the given value in your question. Okay, so you will get the partial pressure of oxygen 744.2 mm mercury. So next question, you want to find mole of oxygen. Okay, number of mole of oxygen collected. So by using ideal gas equation, PV equals to nRT. So you rearrange this equation, you can find mole of oxygen directly, but you need to substitute here pressure of oxygen. So pressure of oxygen, you calculate already 744.2 millimeter mercury, and then convert to ATM first. Okay, kamu akan dapat 0.9792 ATM times volume 0.325 liter, okay, divided by the gas constant 0.08206 times 298 temperature in Kelvin, and then you will get your answer mole in 0.013 mole. For the next question, the mass of sodium chlorate decomposed. So you want to find mass of your sample that decompose. Okay, so from the balance equation that we write before, 2 mole of sodium chlorate will produce 3 mole of oxygen gas. So kenapa kita compare dengan gas? Sebab kita ada information about the partial pressure of this oxygen gas. Okay, so if you have for previously, kita dah calculate mole of oxygen is 0.013 mole, and then do the calculation to find mole of sodium chlorate in the reaction. You will get the answer here 8.67 exponent negative 3 mole. And then when you want to find mass, okay, so mass is equal to mole times molar mass. So molar mass of NaClO3 is this much, 106.5 gram per mole. So your final answer will be 0.923 gram. Okay, for the next example, CaCO3 will decompose into CaO, calcium oxide, and carbon dioxide gas, CO2 gas, and at 30 degrees Celsius, a volume of 107.3 milliliter of gas was collected by water displacement method at the total pressure of 1 atm, and then calculate the number of mole of carbon dioxide, and then find the mass of the CaCO3 decomposed. So the same step as previous question. Okay, so to find number of mole of CO2, so you want to find NCO2. Okay, so for mole of CO2, you can find from, you can also calculate, okay, NCO2 is equals to N total, mole total minus mole of H2O. Okay, so to find, by using this method, first you need to find mole total. So by using PV equals to nRT, kamu akan dapat mole total is this. Okay, next, when you want to find mole of water, so using this formula, sebab kita dah ada mole total, just substitute into the equation, you will get mole of H2O 1.8 exponent negative 4 mole. Okay, so you can substitute into this formula to find mole of CO2, and then you will get 4.135 exponent negative 3 mole. Okay, for the next question, the mass of the limestone decomposed. So from the balance equation, 1 mole of CaCO3 will decomposed into 1 mole of CaO and 1 mole of CO2. So to find the mass of the limestone CaCO3, okay, mole of, you already calculated before, mole of the gas. Okay, so kita ada information about mole of CO2 gas is 4.135 exponent -3 mole. Okay, so since from the balance equation 1 mole of CaCO3 will produce 1 mole of CO2. So if you have 4.135 mole of CO2 means you will also have, it is from CaCO3, 4.135 exponent -3 mole of CaCO3. Okay, and then when you want to find the mass, mass is equal to mole times molecular mass. So times 100.1 gram per mole, and you will get the final answer 413. So you will get the final answer as this, 0.4139 gram.